Welcome to this case study presentation of a leakage of closure caps in outer concentric tubes of a waste heat boiler in an ammonia plant. The case will deal with hot gas corrosion in unexpected areas. This is a typical sketch of the concentric waste heat boiler tube. You can see there is the two tubes, outer tube and inner tube. The boiler feed water comes in at the inner tube and gets out on the outside of the outer tube. In this process, it gets heated up by the heat coming from the outside, and this is the closure cap, which is the main part of the study. It got deformed and holes have been formed. And you can see the closure caps as pulled out from the bundle. These are the closure caps here. And what you see is an outer tube, the closure cap, and there is an inner tube. The boiler feed water comes in the inner tube and gets heated up because of the high temperature coming from the distributor, and that gets heated up. And unfortunately, after a short period of time, the closure caps started giving problems. And this is the typical problems in the closure cap. And the closure cap became very soft, leading to bubbles. You can see the bubbles. It is actually a plastic deformation at a temperature more than what it can tolerate. And that means this has become thinned down like a balloon, and that closure cap started leaking after a certain deformation. So once that leaks, the boiler feed water leaks, and then the operator will come to know that boiler feed water is leaking. This is a cross section of the waste heat boiler. You can see the concentric boiler tubes here, and the boiler feed water, as mentioned in the earlier, entry through the inner tube, and then the steam exits of the outer tube. And the outer tubes closed at the bottom with hemispherical caps. And the whole tube bundle hangs in the shell. The brownish shell. The whole thing is hanging there, and the hot synthesis gas enters the shell through a type 310. This is a distributor, and this is made of type 310 SS, which is a normally designable high temperature stainless steel. But unfortunately, this has got deformed. You can see it is here, damaged distribution plate. The damage means it got cut off from the shell, and then it fell down, and then it became non-uniform heater. So that is a story. And the damaged distributor deformed and seen at a closer view. You can see the deformation here. It is because of the deformation normally occurs due to high temperature exposure. And this fell down, and this gas, instead of normal distribution through the holes, the gas the, flown up by a side angle because the distribution fell down. And so the waste heat boiler, concentric tubes, bottom closure caps leaked. This is the steps involved. The distributor highly deformed due to high scale and due to high temperature and scale, and fell off. The bottom caps deformed and punctured because it is non-uniformly heated. Not all the tubes are uniformly heated, only certain portion were heated. The bottom caps in that portion deformed and punctured, resulting in leakage of boiler water inside the hot shell. The hot gases, flowed up non-uniformly, leading to only certain tubes getting heated up, beyond the design temperature, resulting in deformation of the caps and external boiler tube puncturing, leading to water leakage. There is an external boiler tube that got punctured. And this is the diagnosis and recommendation. The primary diagnosis is a low resistance MOC for the distributor. You may recall the distributor is the plate formed with a series of holes inside. So 310SS is not sufficiently oxidation resistant at the gas inlet temperature at this operation. In general, 310SS is a high temperature grade, but for this condition, it is not sufficiently oxidation resistant. So the recommendation is change the distributor MOC to 253 MA, which is a special grade developed to withstand higher temperatures than 310SS with higher resistance to higher temperature oxidation, scaling and to plastic deformation much better than 310SS. So here is a comparison for 253 MA, 310SS. You can see mostly the chromium is all comparable level. You can see special additions like silicon, high increase in carbon, which will increase high temperature resistance, special additions of nitrogen, and special addition of a rare earth element like cerium. These are the ones which give higher resistance to high temperature oxidation, and that's the one, that is the reason 253 MA has been recommended for this service. So thank you very much for this presentation on a high temperature oxidation study. Thank you.